Now we're going to take a look at vertical stretches. Now, when you have vertical transformations, like we saw with the flip, they're a lot easier to understand than horizontal. Let's take a look. First of all, we're going to do f of x equals 2x squared. So here we have x squared, which is our parent function. Notice what happens when we put a 2 in front of the x squared. Now, as you can see, our green function, our transform function, the y values went up from the parent function, and then that's why we call it a vertical stretch. It could be viewed as a horizontal shrink because the x values went in, and that's one way of looking at it. But notice that the 2 is multiplying the y values. The x squared gives you the y value, right? So the 2 is multiplying those to get you new y values. And notice too that every y value doubled given the same x value. So for example, p of negative 2 would be 4, right? Or, well, our new y value for f of x is 8. It's double that. P of negative 1 is 1. F of 2 is 2, twice that. So that's why it's considered a vertical stretch, because the y values in this case are doubled. If we look at x cubed, we can see the same thing. For example, p of 2 is 8. Well, we can't see it because it's off the graph, but f of 2 would be 16. It would be double that. P of 1 is 1. P of 2 is 2. It's twice that. And what was the other one I was going to look at? Absolute value of x, okay? So here we have, we'll just see the animation again. When we put a 2 in front of the x, the y values are doubled. For example, p of 5 is 5. F of 5 is 10, it's twice that. So the real question is, why does that happen? Well, again, it's a lot easier to explain than horizontal transformations. I had vertical flip there, it should be vertical stretch. Okay, so let's see why. P of x is equal to x squared, p of 1 is 1. Now notice, if we just put a 2 in front of the x squared, we're just taking this y value and we're multiplying it by 2. Therefore, we're just doubling it, and that's why it's stretching. Same x value, the y value has been doubled. Let's look at p of 2. P of 2 is 2 squared, which is 4. Well, again, I'm just taking that 2 squared value 4 and doubling it because it's 2 times x squared to get 8. So it's very, very easy to see why it's vertically stretched, in this case by a factor of 2. We can see that when a is 2, the parent graph stretches. In general, why is that? Well, whatever the function is, let's say it's square root of x, x squared log x, you're just multiplying that by 2. So in effect, I can use an arrow here. You can replace whatever that function is with p of x, because that's what it is, right? P of x is x squared. And so you're just doubling whatever that y value is to get your new y value. I mean, it's just literally that simple. Suppose p of x is the parent graph and f of x is the transform graph. And suppose f of x is equal to 2 times p of x. It follows that 2 times p of x equals f of x, right? Because you're just flipping this equation, and therefore you can take any y value for your parent graph and multiply by 2 to get the new y value for your transformed graph. In other words, the y values of p of x are stretched by a factor of 2 to reach the y values of f of x while keeping the same x values. Again, let's just look at that one more time. This is a good example of the absolute value function. Every single x value stays the same as the y values are doubled. Here is a the parent chart for x squared, negative 2, negative 1, 0, 1, 2, and our corresponding y values. Here is our transformation function, f of x equals 2x squared. All we're going to do is take the y values. Again, for vertical transformations, the y values are changed, not the x. It's vertical, right? So obviously the y is changed. So take these y values and just multiply them by 2 to get your new f of x values. So for example, 4 times 2 is 8. That gives me my new function value while keeping the same x value. Same thing down here. So bottom line is that you end up with this chart, same x values with the y values doubled for f of x equals 2x squared. And again, let's go here. This is what it looks like. For example, p of 1 is 1, but f of 1 is 2. It's doubled. P of 2 is 4, but f of 2 is 8. It's been doubled. That's it for this video of explaining why it's vertically stretched by a factor of 2 when there's a 2 in front of the parent function. If you have any questions about this, let me know.